Today we're going to look at the fundamental theorem of algebra. And the fundamental theorem of algebra says that if we have a polynomial function of a degree that is greater than or equal to 1, it has at least one zero, where the zero may be a complex number. And then of course the corollary to that is every polynomial function of degree n greater than or equal to 1 has exactly n zeros, including multiplicities. So I'm going to try to explain to you exactly kind of what this means. What this basically says is whatever degree of a polynomial we have, whatever that degree is, that's how many zeros we really have, whether they be real or whether they be complex numbers. And I've got a couple of graphs I'm going to try to help to use to illustrate that. So I'm going to pull this first graph in, and I have the graph of this polynomial, 3x to the third plus 5x squared minus 27x minus 36. And if you noticed with this graph on this thing, it crosses the x-axis at 3 different points. That tells me that this third degree polynomial is supposed to have 3 zeros, and because it crosses the x-axis at 3 different points, that means that all 3 of those zeros are real numbers. And we could get at those by using some of the techniques that we've learned about factoring and about the quadratic formula and long and synthetic division of polynomials, and we'll get into that later. But we could actually go and find these, or we could use our calculator and we could just figure out what those points are. We're not going to do that right now because that's not really relative to what we're doing. But I just wanted to help you see that since this is a third degree polynomial, it has 3 zeros. Now, let me pull in another third degree graph that I have. This polynomial here is also a third degree polynomial, but in this case, notice that it only crosses the x-axis in 1 point. But it should still have 3 zeros. And in fact, when I work this polynomial out and solve it, I'll find out that one of its zeros, which is x equals 0, which I can actually see here, that's one of them, and that's the real zero that I have. But then also I'll find out that I have 2 complex zeros also, which are x equals -1 plus the square root of 3i, and x equals -1 minus the square root of 3i. Those are both complex numbers. They are complex conjugates. So one of the things that we're going to figure out is when we have conjugates, or when we have a complex solution, you have to also consider its conjugate. So for example, if I was given the zeros of this polynomial, say this one, and I was only given this complex part of it, I would have to come up with the second complex part of that in order to be able to reconstruct the polynomial. And that's one of the things that we're going to look at in the next few videos, is how to actually construct a polynomial based on the zeros that are given.